Before Cantor, no one had really understood infinity. It was a tricky, slippery concept that didn't really seem to go anywhere. But Cantor showed that infinity could be perfectly understandable. Indeed, there wasn't just one infinity, but infinitely many infinities. First, Cantor took the numbers 1, 2, 3, 4, and so on. Then he thought about comparing them with a much smaller set, something like 10, 20, 30, 40. What he showed is that these two infinite sets of numbers actually have the same size because we can pair them up, 1 with 10, 2 with 20, 3 with 30, and so on. So these are the same sizes of infinity.
But what about the fractions? After all, there are infinitely many fractions between any of the two whole numbers.
So surely the infinity of fractions is much bigger than the infinity of whole numbers.
Well, what Cantor did was to find a way to pair up all of the whole numbers with an infinite load of fractions. And this is how he did it.
He started by arranging all the fractions in an infinite grid. The first row contained the whole numbers, fractions with 1 on the bottom. In the second row came the halves, fractions with 2 on the bottom, and so on. Every fraction appears somewhere in this grid. Where's 2/3? Second column, third row. Now imagine a line snaking back and forward diagonally through the fractions. By pulling this line straight, we can match up every fraction with one of the whole numbers. This means the fractions are the same sort of infinity as the whole numbers.
So perhaps all infinities have the same size. Well, here comes the really exciting bit, because Cantor now considers the set of all infinite decimal numbers.
And here he proves that they give us a bigger infinity. Because however you try to list all the infinite decimals, Cantor produced a clever argument to show how to construct a new decimal number that was missing from your list. Suddenly, the idea of infinity opens up. There are different infinities, some bigger than others.
It's a really exciting moment. For me, this is like the first humans understanding how to count things. But now we're counting in a different way. We're counting infinities.